Common Gateway Interface is a standard method used to generate dynamic content on web pages and web applications. CGI, when implemented on a web server, provides an interface between the web server and programs that generate the web content. These programs are known as CGI scripts or simply CGIs. They are usually written in a scripting language, but can be written in any programming language. History: in 1993, the World Wide Web was small, but flourishing. www software developers and website developers kept in touch on the www talk mailing list, so it was there that a standard for calling command line executables was agreed upon. The NCSA team wrote the specification. However, NCSA no longer hosts this. The other web server developers adopted it, and it has been a standard for web servers ever since. A work group chaired by Ken Core started in November 1997 to get the NCSA definition of CGI more formally defined. This work resulted in RFC 3875, which specified CGI version 1.1. Specifically mentioned in the RFC are the following contributors: Rob Mercool, John Franks, Ari Luotanen, Tony Sanders, George Phillips. Overview: each web server runs HTTP server software, which responds to requests from web browsers. Generally, the HTTP server has a directory, which is designated as a document collection of files that can be sent to web browsers connected to this server. For example, if the web server has the domain name example.com, and its document collection is stored at localhost in the local file system, then the web server will respond to a request for HTTP, example.com/index.html by sending out the file at localhost index.html. CGI extends this system by allowing the owner of the web server to designate a directory within the document collection as containing executable scripts instead of pre-written pages. This is known as a CGI directory. For example, localhost CGI bin could be designated as a CGI directory on the web server. If a web browser requests a URL that points to a file within the CGI directory, then, instead of simply sending that file to the web browser, the HTTP server runs the specified script and passes the output of the script to the web browser. That is, anything that the script sends to standard outputs is passed to the web client instead of being shown on screen in a terminal window. The CGI system also allows the web browser to send information to the script via the URL or an HTTP post request. If a / and additional directory name, S, are appended to the URL immediately after the name of the script, then that path is stored in the pathinfo environment variable before the script is called. If parameters are passed to the script via an HTTP post or GET request, then those parameters are stored in the query string environment variable before the script is called. The script can then read these environment variables and adapt to the web browser's request. Syntax: the following CGI program shows all the environment variables passed by the web server. If a web browser issues a request for the environment variables at HTTP, example comprehend PLBAR, var1 equals value 1 and var2 equals with %20% %20 encoding, a 64-bit Microsoft Windows web server running Cygwin returns the following information. From the environment, it can be seen that the web browser is Firefox running on a Windows 7 PC, the web server is Apache running on a system that emulates Unix, and the CGI script is named CGI bin10pl. The program could then generate any content, write that to standard output, and the web server will transmit it to the browser. The following are environment variables passed to CGI programs: server-specific variables, server software, name version of HTTP server. Server name, host name of the server, maybe .decimal IP address. Gateway interface, CGI version. Request-specific variables, server protocol, HTTP version. Server port, TCP port. Request method, name of HTTP method. Pathinfo, path suffix, if appended to URL after program name and a /. Path translated, Corresponding full path as supposed by server, if path info is present. Script name, relative path to the program, like script CGI. Query string, the part of URL after character. The query string may be composed of name equals value pairs separated with ampersands when used to submit form data transferred via GET method as defined by HTML application XWWW formal encoded. Remote host, host name of the client, unset if server did not perform such lookup. Remote ADDR, IP address of the client. Auth type, identification type, if applicable. Remote user used for certain AUTH types. Remote IDENT, CIDENT, only if server performed such lookup. Content type, internet media type of input data if put or post method are used, as provided via HTTP header. Content length, similarly, size of input data if provided via HTTP header. Variables passed by user agent contain values of corresponding HTTP headers and therefore have the same sense. The program returns the result to the web server in the form of standard output, beginning with a header and a blank line. The header is encoded in the same way as an HTTP header and must include the MIME type of the document returned. The headers, supplemented by the web server, are generally forwarded with a response back to the user. Deployment. A web server that supports CGI can be configured to interpret a URL that it serves as a reference to a CGI script. A common convention is to have a CGI bin/directory at the base of the directory tree and treat all executable files within this directory as CGI scripts. Another popular convention is to use file name extensions. For instance, if CGI scripts are consistently given the extension CGI, the web server can be configured to interpret all such files as CGI scripts. While convenient, and required by many pre-packaged scripts, it opens the server to attack if a remote user can upload executable code with the proper extension. In the case of HTTP put/or posts, the user-submitted data are provided to the program via the standard input. The web server creates a subset of the environment variables passed to it and adds details pertinent to the HTTP environment. Uses. An example of a CGI program is one implementing a wiki. The user agent requests the name of an entry. The web server executes the CGI. The CGI program retrieves the source of that entry's page, transforms it into HTML, and prints the result. The web server receives the input from the CGI and transmits it to the user agent. If the Edit This Page link is clicked, the CGI populates an HTML text area or other editing control with the page's contents, and saves it back to the server when the user submits the form. Alternatives. Calling a command generally means the invocation of a newly created process on the server. Starting the process can consume much more time and memory than the actual work of generating the output, especially when the program still needs to be interpreted or compiled. If the command is called often, the resulting workload can quickly overwhelm the server. The overhead involved in interpretation may be reduced by using compiled CGI programs, such as those in C++, rather than using Perl or other interpreted languages. The overhead involved in process creation can be reduced by techniques such as fast CGI that pre-fork interpreter processes, or by running the application code entirely within the server, using extension modules such as mod.php. Several approaches can be adopted for remedying this. The popular web servers developed their own extension mechanisms that allows third-party software to run inside the web server itself, such as Apache modules, NSAPI plugins and ISAPI plugins. Simple Common Gateway Interface or SCGI. Fast CGI allows a single, long-running process to handle more than one user request while keeping close to the CGI programming model, retaining the simplicity while eliminating the overhead of creating a new process for each request. Unlike converting an application to a web server plugin, fast CGI applications remain independent of the web server. Replacement of the architecture for dynamic websites can also be used. This is the approach taken by Java EE, which runs Java code in a Java servlet container in order to serve dynamic content and optionally static content. This approach replaces the overhead of generating and destroying processes with a much lower overhead of generating and destroying threads, and also exposes the programmer to the library that comes with Java Platform, standard edition on which the version of Java EE in use is based. The optimal configuration for any web application depends on application-specific details, amount of traffic, and complexity of the transaction. These trade-offs need to be analyzed to determine the best implementation for a given task and time budget. See also, Fast CGI, Rack, Web Server Gateway Interface, Perl Web Server Gateway Interface, References. External links, GNU CGI-CC, a C++ class library for writing CGI applications, CGI, a standard Perl module for CGI request parsing and HTML response generation.